Hello, it's Professor Young, back with you to cover Chapter 6, the Integumentary System. As we discussed in class, we'd only be spending one day on this, as we definitely have other systems that we need to move on to that are going to take some time because of their complexity. And so we will go through this. The PowerPoint is posted under shared files. There will be a couple extra slides in there as opposed to what I am kind of combining and condensing through here. So please feel free to check under shared files and make sure you have all of the information. Remember, we did not finish all of the notes in class, and so you're going to have to go back and look for some of that information as well. Under shared files, as well as represented here. And so as we prepare to begin, and as we discussed in class today, the integumentary system not only includes the skin, but it also includes hair, nails, and the cutaneous glands that we will be paying attention to a little bit more. One of the concerns that we have with the integumentary skin is that it is the most visible of all of the organ systems. And because it's the most visible, it's exposed to a lot of environmental conditions. It's exposed to a higher risk of injury and damage. It's exposed to a higher risk of infection and chemical burns and injuries sustained through chemical contact. And so there's quite a few obstacles that the skin needs to overcome because of the fact that it is exposed to the outside world. Here you can see a diagram of the structure of the skin. We have multiple layers. The first layer that you need, that you should be aware of, has to do with this guy right here, that being the epidermis. And then, again, moving downward, we have a rather large area here referred to as the dermis. And finally, we have this lower area right down in here. That would be considered the hypodermis. And the hypodermis is mainly the subcutaneous fat layer of the skin that provides cushioning, insulation, as well as some energy points in there as well. If I was drawing this a little bit more carefully, you would actually see that the subcutaneous would come down into that area there, and then this whole area right in here would be all part of the dermal area. Just making sure that we are clear on that. We see multiple structures associated with the skin besides the layers. Of course, here we have hair follicles. Over in this area here, we've got blood vessels. We've got down in this area, of course, the shaft, the bulb of the hair. We've got multiple glands that are associated with the skin. Of course, down here have veins. We have arteries and blood vessels down in this area. And the all-important, the subcutaneous fat, the adipose tissue, as is stored there. As we will determine as time goes on, this, let's see here, this layer right in here, that takes up right all up in here, that of course is going to be made up of epithelial tissue, as opposed to this layer, the dermal layer, which here is connective tissue, mainly a lot of areolar tissue. It is vascularized, as you can see, with capillaries. And then we have that final area down in this area here which for our purposes, again, is going to be adipose tissue, which is a type of connective tissue. So we do have different tissue types present within this area. A couple little tidbits of information as we move forward here. The skin and subcutaneous tissue, it is the heaviest organ out of all the organs within the body. As we mentioned already, two main areas, the epidermis, which is the stratified squamous, again, it's epithelial tissue, and then the dermal layer is connective tissue. Of course, the hypodermis still, again, is connective tissue. We talked quite a bit about today about the thickness of the skin, the fact that we have thicker skin on the palms and the soles, as well as on the fingers and the toes that give us fingerprints and specific, I guess for lack of a better term, the toe prints on the undersides of our fingers and toes. That thickened skin is keratinized, meaning that it has a thicker layer of keratin, more tightly packed, tightly dense keratin fibers found within them. That thicker skin does have sweat glands, but you will notice that it is absent of hair follicles. For those of you that are actually looking at your palms right now, I hope you can vouch for the fact that you have no hair on your palms. If you do, please see your doctor, as that is probably not a normal thing for you to have, because that was a joke, folks. Because there are no hair follicles, we also have no sebaceous glands or oil glands. One of the things that makes your hair on your head oily is the presence of sebaceous glands, and they are associated with hair follicles. So if you don't have hair follicles, you're not going to have sebaceous glands. And then, of course, the thinner skin, which covers the rest of the body, it does not need to be thick unless it is injured and going through the healing process, as discussed in Chapter 5. But that does possess hair follicles. It does have sebaceous glands. It does have sweat glands. It has everything that you would expect a normal hair to have. Functions of the skin includes resistance to trauma and infection. That is largely due to our buddy keratin, which we've again talked about. We've discussed. We know that keratin is the intermediate filament of epithelial tissue. And we discussed today the fact that as you move up from the stratum basal layer, the presence of the epithelial cells begin to elongate and flatten, and that is because of an increased production of keratin fibers, which basically becomes starts to create densely packed areas. Skin forms a barrier so that we try to stay waterproofed as we can, protection against UV radiation and other harmful chemicals, vitamin D synthesis, sensation. If someone walks up and punches you, or you drop something on your toe, you feel it. You feel it because the skin is sensitive. It has thousands of nerve endings all across it. Of course, our skin helps us to maintain homeostatic internal temperature, thermoregulation. And it does that through the constriction or the opening up of blood vessels to either allow us to shiver or to sweat and release heat. And then the transdermal absorption, giving ourselves injections through the skin down into that subcutaneous level, which has plenty of access to blood vessels. So that the drug can go ahead and either enter into the muscle or into the bloodstream and carry to wherever it needs to find itself. The epidermis is the top layer of skin, as we discussed in class today. My suggestion would be, if you have not already printed out the diagram of the structure of the skin, to go ahead and do that. And I would even do that before you even continue. Currently, you are on slide 6 or page 6, and so if you need to hop out of this program, get yourself into the shared files under Chapter 6 and print yourself out Figure 6.1, so that way you have something to look at. And while you're at it, I would even consider printing out Figure 6.8, so that way you have that as well. That is the layers of the epidermis. You can always come back into this program and pick up right here, but it's going to be helpful for you to look at that information as we go through it. So as I was saying, the epidermis is keratinized, stratified squamous, high volume of keratin fibers. They are all dead cells at the top, and so there is no need for them to be vascularized. They don't need a blood supply. They're already not living. They've moved up through the epidermal layers and are doing quite well right where they are. And of course, because it is epithelial tissue, it's going to lack blood vessels anyway. The diffusion of nutrients is going to happen through the dermis, between that and the subcutaneous fat layer, the hypodermis, as that does have capillaries and that does have arteries and veins that are running through that. Again, there are nerve endings for touch sensation and pain sensation. They are scattered throughout everything that is there. We find within this epidermal layer that we have multiple layers. Let me just point out to you, here is the dermal layer. This here would be the beginning of the dermal layer. You can see that there is not a nice straight line that definitively separates out the epidermis from the dermis. It is rigid, but there is a stark difference in the appearance. You can see the epithelial cells that are present there. You can see the lack of epithelial cells or lack of a definitive cell type within this. And again, this is, when we talk about the dermal layer, this is areolar tissue. There may be some dense irregular tissue in here as well, but it is definitely not epithelial. It loses all characteristic. And the big difference here is the fact that you've got these red things, capillaries, that are running through this, and that is going to supply a means to bring nutrients, to bring oxygen, and to remove waste products. And that's just carbon dioxide from these different layers. Within this, we can start to depict and see and identify all of the above. The different layers of skin. And to start out, we have the stratum basal layer, which fairly, for the most part, takes up right there where the yellow is. Within this layer, we see typically cuboidal cells, and you see the presence of those cuboidal cells. Don't tell me you don't see those cuboidal cells. There they are, right there. Bam, there it is, right there. Bam, there's another one right there. Bam, here's another one over here. Bam, here's one right there. So we have the presence of cuboidal cells there. It is a single layer. Within this, very often we have keratinocytes that are resting on this membrane. The keratinocytes are there to help to produce new keratin fibers, new cells. You can see the presence of stem cells very often within this base membrane. All right, right there. There's that. Again, we're in the stratum basal layer. Here's another stem cell right there. And so you see those types of cell structures. We also see within this layer melanocytes. Of course, this here again is going to help to produce, and the melanocyte in that case there is right there, and that is going to help to produce melanin, which, as we talked about today, gives us pigment, skin color. The keratinocytes will also begin to migrate northward, if you would. And when we talk about northward, we're talking about towards the surface, where, what happened? Right there. And again, these would become dead keratinocytes up in that area that are going to be creating that top layer. But we're not there yet. We're still dealing with the basal layer. If we continue to move up here, as we will do, we move into the next area, which for us is a rather large area. It is indeed the largest area of the epidermis. And I'm going to try to keep this as focused on this as I can, although please understand these layers are not exactly what I would consider to be even. But in between the red there, we have the next layer of concern, which is the stratum spinosum. Again, present throughout here are the keratinocytes. Right there, let's say right here. There's one, there's one. All of these cells in here are all keratinocytes. These are all epithelial cells that are going to be moving to the stratum corneum. The lower the cells in this layer, the more the capability is still there to undergo mitosis. As they reach the surface, they begin to lose that ability to perform mitosis, and they begin to flatten themselves out. That flattened, elongated appearance is due to the fact that there is much more keratin being produced within the cell. And it's the presence of those keratin filaments that cause the cell to flatten. Another cell type that is associated with the spinosum layer is the green goblin. That is kind of right there in the middle. And that there is a dendritic cell, Langerhans. Basically, that is there to help fight infection. It is there to engulf, if you would, any kind of bacteria, any kind of virus that may be trying to penetrate into the skin and get deeper. It wards it off so that it does not reach the blood system, at which point in time it would have complete access to just about anything and everything that it wanted to have, which would not be a good thing for us. And so that is the stratum spinosum. The next layer that we have for us to consider is a much smaller section. It's these guys right in here. As I again try to separate them out. Let's see what happens here. right in there. There we go. It's that darkened layer, the stratum granulosum. And within that stratum granulosum, all you need to know is that it is about 3 to 5 layers thick, and that is all of the heaviest and flattest keratinocytes that are present within the skin. Consider that the final days on the ranch before they are sent out to epithelial heaven, which in this case here would be the stratum corneum. And so they are the densest of the epithelials, squamous epithelials. They have the highest percentage of keratin filaments within them. And again, that they are just one step closer to the stratum corneum. We have a thin layer that happens kind of right in between the granulosum and the corneum. I just highlighted that in blue. That would be the stratum lucidum. And the whole point of the stratum lucidum is doesn't really serve a purpose other than it's a division. The keratinocytes, the epithelials, the squamous epithelials that are there that contain the high levels of keratin are densely packed. And that's kind of the transition between the granulosum and the corneum cell type. And then we have the stratum corneum. And this is the one that all of you are probably most familiar with, since it involves the part of the skin that is visible, or most visible by all of us. And it is outlined here in the orange, right there and right there. You can see it. It would be that light purple. And that is up to 30 layers of those dead, scaly, squamous epithelial cells that we've been referring to as the keratinocytes. They are keratinized, and so they tend to be a little bit thicker, very much dead, high proportion of keratin filaments within them. Durable surface, although they do maintain some flexibility. The cells flake off repeatedly over and over again. They are resistant to abrasion, which is why you don't puncture holes into your skin automatically. They are resistant to penetration, which is a good thing, and they are resistant to water loss unless you're going through a sweat pore. That little sweat pore on this diagram is indicated right there. That's one way that water would escape from that area. And so there's a lot going on there in this slide here. For all of those notes that I have just mentioned here, please refer back to the PowerPoint that was posted under shared files. And so now we have the dermal layer of the presentation. Again, this is made up of connective tissue. Because it's made up of connective tissue, specifically areolar tissue, it's going to be composed of collagen fibers. Yes, you will have some elastic fibers in there. Yes, you will have some reticular fibers in there, which we know is a special case of dense irregular connective tissue. And the main cell type is fibroblasts. And the fibroblasts there are present to maintain those collagen fibers, which again aids in keeping the skin elastic, smooth, non-wrinkly, young-looking, non-aged, non-beaten-up type of skin. The skin that we all try to maintain as long as we can. This is a layer that is well supplied with blood vessels, specifically capillaries. There are sweat glands found in there. There are the sebaceous glands, which are your oil-secreting glands. There are nerve endings in there. The hair follicles are in there. If we're dealing with fingernails, the nail beds or the nail roots are found within the dermis. And so there's a lot that goes on in here. As opposed to the epidermis, which is mainly there for the generation of squamous cells for protection, the dermis we see a lot more happening. It's a lot more of a complex area and region. Again, if we go back to this slide here, you can see here's a sweat gland right there, and that is fairly visible there. Here's the hair. I think we've already kind of pointed some of this stuff out. We've got the capillaries right there, so on and so forth. And so they are definitely present. Here is, just in case it's not as visible as we would like, right in this area, right there, is the sebaceous gland. That's going to be the oil secretion gland. Remember, we said specifically that the sebaceous glands are only present during or in conjunction with hair follicles. And then we come to the hypodermis, that subcutaneous fat layer that we all have, not to be confused with belly fat in any way. All right, but that is that layer down deep. I don't know if you could actually see that or not. Let me switch colors here. And so this is the layer down here that we are referring to when we're talking about the hypodermis. Again, areolar tissue, adipose tissue, mainly adipose tissue down there, provides a padding for the skin. Drugs are introduced into this area through the injections. You can see it's highly vascularized, so the drugs have a good chance of being picked up and absorbed by the arteries and the veins in that area and distributed throughout the body. Thermal insulation. And as we mentioned in lecture today, guys, we win one on this one. Females tend to have a 8% thicker layer of subcutaneous fat under the tissue than what we do. Why? Not sure. Other than the fact that males tend to have a higher percentage of muscle as compared to females. Other than that, I don't have an explanation for you. Of course, this is kind of where we left off in lecture today, was talking about skin color. I'm going to post the link to that presentation that we were looking at today on the bookmark site, so please go ahead and check there for that. But melanin is what we are talking about. That is the factor that affects skin color. Melanin is a chemical produced by the melanocytes, and it accumulates within the keratinocytes that we've been talking about, that we know forms the outer layer of skin. It works its way, it originates within the stratum basale and then works its way up into the spinosum, and then finally appears on the external layer of the skin, the corneum. People of the darker skin tones simply have a higher quality of melanin. We all have the same amount of melanocytes. It's whether or not the presence of melanin is greater or lesser that's going to really determine the skin tone. And of course, the amount of melanin that we have is going to vary with the overall exposure to UV rays. Specifically, and this is where we were leaving off at, it's not UVC that is the problem. It's generally speaking, it is UVA and UVB where the concern comes into play at. UVC is fairly well blocked out by the ozone layer before it even comes in. So again, take a look at that video. I would strongly suggest it. I'm going to post it as a link under the bookmarks for you. Hair and nails, again, these are accessory organs to the skin. Both the hair and nails are composed of keratinized cells, epithelial cells that have an extremely high amount of keratin filaments within them. Tends to be a little bit harder than the skin, as you can feel. Hair is defined as a slender filament of keratinized cells, and it's going to grow from that hair follicle. You can go back and check out that picture that I was showing you earlier. But remember, the hair follicle is located within the dermis. Actually, here goes the structure of that hair follicle right here. So this here would be a picture almost down into the hypodermis. You should be able to easily pick out, and if you can't, shame on you. What is that cell type right there? What is that cell type right there? What is that cell type right there? You got a bunch of them. They're white. They're fluffy. They look like marshmallows. They are adipose tissue, and so that's a key sign that you are definitely at the border of the dermis, entering into the hypodermal layer. And of course, here is right there is the hair shaft, and that is where the hair is going to be growing out of. The bulb. Let me just do a little bit of a switcheroo here. The bulb is going to be down right there, whereas the root is going to be right here, and then the shaft is right there. And then the dermal papillae, that's that bud that is found within inside of the bulb. It actually looks like a little seed pod, if you would. And again, that is located right here inside. Let me redo that. I don't like the way that one looks. But I don't like the way that one looks either. Let's try this again. Third time's a charm. Or not. All right, right there. At any rate, you get the idea. That clear center area there, that's the dermal papillae. And that's basically where the nutrients are being fed into the hair shaft. So there you go. A couple more structures that you need to be familiar with, and that it more so has to do with this area up in here, right here. And that's the medulla, the cortex, and the cuticle. The cuticle is the further outside edge, whereas the cortex would be the inside, and the medulla that would also be on the inside as well. And you can see that information there, and they are labeled for you appropriately. Here is the medulla, as you can see. The medulla there would be in the middle, and then you have the epithelial root over here, and you have connective tissue out here, again with the cuticle being right there, and the cortex being right in here. So you can see those structures right there. A couple more slides that we need to consider here. I'm going to talk a little bit about sweat glands. Just a little bit about sweat glands, not too much. Actually, before I do that, let me back up to the hair slide here. I do want to mention that on average, the average person has about 100,000 hairs on their head. Guys, we usually have, if we have a beard, we have about 30,000 hairs that equal the beard. The face has about 10 times as many hairs as the limbs and trunks. The limbs and trunks have between 55 and 70 hairs per cubic centimeter. And so the face would have about 10 times that much. Of course, if you shave, you're going to have a lot less hair. But that's nothing that's totally in your control, I guess is how I should say that. So again, the limbs and the trunks have about 55 to 70 hairs per centimeter squared. The face has about 10 times as that. A beard would be about 30,000 hairs, and the average person on their scalp, on top of their head, have about 100,000 hairs. I would have considerably less, probably. Let's not pick on young now. I probably have between 30 and 40,000. Maybe I'm being optimistic. Who knows? All right, sweat glands. Let's get to the stinky stuff. Notice the official name of the sweat glands, Sudoriferous. And there you kind of see the auriferous, which means stinky, smelly. And so this is the stinky, smelly gland. We have two kinds of sweat glands. You have the merocrine sweat gland, and you have the apocrine sweat glands. The first type of those sweat glands are associated with the skin. The merocrine glands are associated with the skin. We have between 3 and 4 million of these sweat glands, and it's mainly a watery substance that is released from these glands, as opposed to the apocrine sweat glands, which occurs in areas where you tend to heat up a little bit more, if you would. Say the groin, the anal region, the axilla. You should all be familiar with the axilla. That would be the elbow area. Bearded areas in males. Ducts are basically in and around the hair follicles. And the sweat that is produced there tends to be a little bit thicker, almost mucousy. And this is the sweat that really starts to stink up the place. It's the reason why we use deodorant. And the reason for the odor that it's given off has to do with the fatty acids that are present within there. These are also glands that are associated with pheromones, which is the chemical signaling process that says to the opposite sex, hey, I'm over here, come look at me. It's supposed to be an attraction, although I guess most of the time it's probably not, but that's because we're American. And we are used to other scents that are used as pheromones and not that bodily scents. If we were over in Europe, it'd be a different story. But we're not, so let's move on. Sweat itself really begins as this waste product, if you would, of blood plasma. It contains potassium ions. Very often it will contain urea, lactic acid, ammonia, sodium chloride, hence the saltiness. And so all of that kind of stuff will remain in the sweat. Drugs can be excreted through the sweat. Water, of course, is going to be secreted through the sweat. Typically, the normal person on an average day will produce about 500 milliliters of sweat coming out of those pores per day. While that seems like a lot, it's not. It's typically not enough to form sweat beads on the skin. Diaphoresis, on the other hand, is a sweating with wetness of the skin. So when you exercise vigorously and you've worked up a sweat and that sweat's coming out, that there is what we refer to as diaphoresis. That is a mass exiting of perspiration. And so you're probably looking at about 1,500 to 2,000 milliliters of sweat within that given day. Sebaceous glands, we talked about the fact that sebaceous glands secrete more of an oily composition. They are always associated with hair follicles. It is the sebaceous glands that makes the hair on your head oily if you don't wash it on a daily basis. And so you can kind of see what's up with that there. Lanolin is a sheep oil that is secreted through sebaceous glands. Women who are nursing, very often the areola around the nipple gets very dry and crackly, and doctors recommend lanolin to help re-moisturize that. And then it's sheep oil sweat that you're applying onto the areola of the nipple area there, just in case you were curious. And of course, we wouldn't be complete without talking a little bit of earwax. Ceruminous glands, again, only associated with the ear canal. It's a combination of sebaceous oil as well as dead epithelial cells. The epithelial cells is what really thickens up that oily sebum from the sebaceous glands, and that's what we refer to as earwax. It's good, it's beneficial. You should never clean your ears to the point where you have no more earwax in there. It acts as a waterproofant, and it also helps to kill off bacteria. Your ears are an open canal to your inner body, and so you need some way of killing off those bacteria. And that is what does that for us overall. With that, we've looked at this for about 50 minutes now, and it's time for me to say goodbye. Take a look at this, review this. If you've got questions, email me as always, and if not, jot them down. Check with me before or after lecture and or lab, or as you guys have been doing very well, raise your hand and ask some questions during lecture, and we'll get to it as that way as well. And again, make sure you go back, check out those diagrams that I recommended you to check out under shared files. It's in the PowerPoint for Chapter 6, and go back and check out the bookmark for the video on the evolution and development of skin pigmentation. And on that note, happy studying, and we'll see you soon.